Welcome to qnawire.
Hello everyone, this is the solution to problem 8, chapter 24 of college physics. And for part A, we're asked to find what the field lines of a bar magnet look like. And if you didn't know, these field lines are always pointing from the north to the south pole, and they never cross. That's just generally true for any kind of field line, electric or magnetic. And so this is what the picture looks like. And these lines keep going on forever, and they get weaker and weaker and much further apart as you go farther away from the magnet. So this is part A. This is what your picture looks like. And then in part B, we're asked to find what the generated electric fields are going to be in front of and behind the magnet that is falling down due to pull from the Earth. So here I'm going to assume that the magnet is moving downwards in this picture. So what do we want, right? We know from Lenz's law that the generated electric field is going to be such that the magnetic field that is associated with the current it generates is going to oppose the motion of the magnet. Now, as you can see here from this bar magnet, on the bottom here, you have a B field that is going up. So this is the direction of the B field generated by the magnet. And the same is true on the top here, that is pointing up. This is just directly, you can directly see this from the picture in part A. So then what do we want? To oppose this motion, we want there to be a south pole over here, so that the south pole that the new magnetic field creates, or is created by the new magnetic field, is going to be pushing this magnet up. So then to generate a south pole, we need the new magnetic field. Let's use it. Let's draw it with the color red. So this is the new magnetic field. And so for this, to find the direction of the electric field that generates this, imagine that there's going to be a current running around in some direction down here that has to generate this magnetic field. And for this, we just use the right-hand rule. So you point your thumb along the direction of this new magnetic field, and then you curl your fingers towards your fist, and that's going to give you the direction of the electric field. So if you had a current, then you would be going around this way, which is, if you look at it from the top, this is going to be a clockwise direction. And so this is going to generate a magnetic field that's pointing down, and so it has a south pole here, which is going to be pushing this magnet up. Okay, so that's the situation on the bottom. What do you want on the top? So on the top, you have a north pole, and to oppose this motion, you want there to be a south pole here, so that this north pole of the bar magnet is attracted to that magnetic field. And so on the top, you want your new B field to be pointing up as well. Because pointing up means that there is a south pole over here. And so again, you're just going to use your thumb on your right hand to point in the direction of this B field, and then use your fingers, curling them towards your fist to find the direction of the E field. So this is the direction of the E field here. And now this is going to be a counterclockwise direction behind the magnet. And so that is